Alright, hi folks, this is the first of the two video segments that I'm going to make for parameterizing an assembly. The first problem that I'm going to do is right here, an assembly consisting of a base and a wedge. And this problem was done using design table before, but now I would like to use to parameterize it. Okay, in other words, alpha, beta, and H, and also material and part number that I'm going to do later on. Okay, the first step is to start with a product file, and immediately we're going to save it. File, save management, save as. On the desktop, I already created a folder right there, and product one. So everything is going to go into this. So insert a new part in there, and let me call this thing the base. So base and base, and we're going to make it. Double click on this. On a convenient plane, on that vertical plane, I will sketch, and it looks like that thing that you saw on the screen a minute ago, something like that. Okay, and then we're going to work on it to make it nice and symmetric. Left edge control, right edge control, middle axis, make it symmetric. This line control, that line control, middle axis, make it symmetric. And I'm pretty sure this is good. Now let's also dimension the stuff that we may want to control. We do want to control this one, dimension. Okay, dimension between this point and that point, and it's the vertical dimension. Oh, I'm sorry. Let me select this dimension, vertical one. Something's going wrong. Control Z. Okay, let's try it a different way. This point, control that point. Sure, I don't need the control. Right click vertical, and then the angle here, this angle, this line, and that line. There we are. Exit, pad it. Where's the pad? Pad. The depth of the pad is not important, so we just use the default value and we put some dummy material on it. So dummy material aluminum on this part, this line right there, and we say OK. All right. Okay, let's go and make the top level right there, top level. Save everything. And then insert a new part, insert a new part. And I'm going to call this thing the wedge. And wedge. Now let's make it. Double click on the wedge. Now we end up in part design, as you can see, on a convenient plane. On that same vertical plane, we're going to draw a profile which resembles that wedge, like this. The only thing is that I'm going to make it symmetric. This line control that line, control the middle axis. We make it symmetric. Left line control right round control middle axis. Also symmetric. Very good. And now we're going to dimension it. This point to that point, but it's a vertical dimension. Remember, this is going to be the same as what's down here. And then angles, this line and that line, this is going to be the same as that angle down here later on, and this line, which has its own numbers. Exit, pad it, same length as this, and we apply some dummy material on it. Apply, I don't know, aluminum on that, and save. Okay. Well, I just happen to make both of these out of aluminum. It doesn't matter. Later on, these are going to be changing according to what you want. Now, save everything. By saving, I go always to the product level, and everything's going to save. Now, what I would like to do, I like to create certain parameters at the assembly level. So make sure you are up there. You are not in one of the parts, up there, which means make sure the double gear appears here, okay, on the right side, assembly design. So I click on f of x, and now I'm going to start my, create my new parameters. Notice that here, the new parameters of the type of specified. So I want 2 angles, 1 height, and 4 of string type. Okay, so let's start with the angle. So new parameter, we call this thing alpha. This is all at the assembly level. So for now, I'm going to make it 30 degrees. Apply. The new one, beta, I don't know, 30 degrees. Apply. Then we want the height. The height of these two, which is going to be length, type length. New parameter, call it h, and give it some value, 1, apply, and then I want 3 string parameters. The first one is going to be base name, how about that, or name of the base. Give it some value, some nominal value, A001, apply. Another one, name of the wedge, I'll call it B001, apply. Then material of the base, mat for the base, some nominal value, gold, remember uppercase G, apply. And another one, name, mat for the wedge, some nominal value, this is string, so steel, apply. And in fact, if you look at it, all the stuff that you created, and these are at the assembly level. It's very important that these things that you create happen to be at the assembly level. And what that means is that the parameters that you're talking about created must be at the very bottom of the tree, below these parts. It should not be in the parts. Okay, now we're going to create our equation. You know, maybe what we should do, we should say, okay, save everything, we're at the assembly level. And I want to remind you how to make sure that these guys show in your tree. Because unless you activate it, they will not. Let me show you, remind you. This was already discussed in the crash course video tutorial for Catia settings. But I'll do it again, mentioning tools, options, infrastructure, product infrastructure, and you select all these tabs. You select the last tab, notice that parameters and relations are saying yes. If I activate it, if I say deactivate this, and there are no relations, but let's hypothetically say I'd say deactivate. Notice that they are gone. The parameters are there. As a matter of fact, if you click on f of x and you say, show me the renamed parameter, they show, but they're not coming up on the screen. And the way we mark your test, if you have a problem like that, we're going to go to that list at the bottom and start changing it from there. If we don't see it there, if we cannot activate it from down here, means that you did not do the way the problem was supposed to be done, and you're going to lose marks, okay? Substantial number of marks, because I'm already making it clear how these are supposed to be done. So let me activate them again. Tools, options, infrastructure, that's already selected. Product infrastructure, that's already selected. Take all the tab all the way to the end. All the way to the end. Tree customization, select this, activate. And if you have any equation, then we will activate and say OK. Notice that parameters appear here, but there are no equations, so that's OK. Now let us go and make our relations, formulas, equations. These are all meant the same thing in the context that we're working with. OK, so click on f of x. An equation means a formula, basically. So you click on the product. All the dimensions show here. So for example, you select this guy, and I want to say add a formula, and this is h. You select this angle, add a formula, rename parameter alpha. You select this height, add a formula, rename parameter, this is h. You select that angle, add a formula, rename parameter, that is alpha. And finally, you select this angle up here, add a formula, rename parameter, beta. Say OK. Now we have to do the strings. So to make our job easier, what I'm going to do is I'm going to say show me all. Okay. Let me close this. First of all, make sure that actually our parts are working. How about that? Before we go ahead and change the names and things like that, let's make sure that these numbers are working. So, for example, let's update everything. Let's say that we go. This is the angle alpha, right? This is the angle alpha. Alpha. Let me make this thing 90 degrees. Okay. Okay. See, this is 90. This is 90. Let's make it 45. Apply. This is 45. This is 45. Let's try beta. Beta is this angle on the top. If I make this thing 90, apply, see that angle became 90 degrees. Let's try h. H is this height. So h, let me try 2 inches. Apply. See, this is 2 inches. This is 2 inches. We have not worked on these things. These we have to work on it, and we're going to do that in a minute. But before I do that, I would like to point out that you will lose marks if you were told that assembly constraints must hold. What that means is that, and this is before I do these strings, coincidence between that edge and this edge, and coincidence between this plane and that plane, and coincidence between this edge and let me see now. This one, do I need it? Yeah, I do need that other constraint. So update. Okay, now if you move these things and rotate them in any way that you want, here is called the manipulation icon in the move toolbar right there. This is very important. So let's do some kind of weird rotation, maybe even some translation. And if I update, they should go back to the original configuration. There we are. So assembly constraints are correct. Now let's go and work on these strings. Okay. So here's what we're going to do. Click on f of x. Okay. Let me factor this with, or not factor it, what do you call it, filter it with a screen, with strings. Okay, so let's see now. If you scroll down here, you will see a base part ID or part number. So let's go, here's base right there, part number. I want this thing to be equal to the string name that I gave it. So add a formula equal to rename parameter name of the base right there. Okay, now find the material for the base, which must be some right here, base material. Add a formula. This must be material of the base right there. Okay, scroll down, find the same, do the same thing for the wedge. This is a part number for the wedge. Add a formula, and it's this string that I want to specify. Which one is that? That was the name. Okay, so that's going to be name of the wedge. And finally, the material for the wedge, which must be somewhere down here. Wedge material. Well, let's see. We are looking for wedge material. It's right there, wedge material. Both of them, remember when I started, make both of them equal to aluminum. So add a formula, rename parameter, and material for the wedge. Okay, so let's find out. Look, let me expand these. Material is right here. Expand this so that you can see. Okay, so let us go and go to this. We already checked the numbers, they're going to work. So let's double click on this branch of the tree. Say name of the base is, let's put something strange. So how about Windsor? Not that Windsor is strange, but Windsor. Notice that if you go up here, the name of that part is changed to Windsor. Let's go to, right now the material is steel. No, it's gold. Okay, so if you go down here to the material for the base, I'm going to change that thing to brass. Okay, so the name is Windsor, part name is Windsor, material is brass. And same thing with the wedge. So if I go to the wedge, name of the wedge, I don't understand why the W does not show up there, but that's okay. So I'll make it Detroit. The name of it, we're going to make Detroit. And the material of it, where is that? Material for the wedge, right there. I'm going to change this thing to iron. Okay, so when I check my this part, which used to be called wedge, okay, the name of it is Detroit and the material is iron. Okay, so we managed to parametrize size. Assembly means that both of these when you change these numbers, they all change, and the assembly fits, of course, the constraints there. And we also managed to parameterize the name of the part, different part, and the material of the different part. Please do not forget that when it comes to writing a test, if it's an assembly problem, you must create your parameters when you are at the assembly level. And we're going to mark these by going to the bottom of the tree and change it from here. Now notice that there are also some relations. These are the stuff that I defined. For example, I selected that vertical dimension and I say it's equal to h. I selected the angle, I say alpha. It's very common that people who don't practice these things sufficiently, when it comes to the test, they write alpha equal to that dimension from the screen, or h equal to that dimension from the screen. That is not parameterizing. But when you say you are parametrizing, means that I'm going to change that parameter. If you say h equal to something, there is no way you can change h. H is specified by the value of that angle. Okay? I'll do one more problem.